There have been a lot of questions concerning the detection of complex organic molecules and most importantly their origin story. Some origin stories stems from, hey, these were coming from simple atoms and elements coming together in a primordial soup to create such complex organic molecules, but not many theories have been coming from how about this was created out of space or before the formation of stars. And this here is the proof thanks to James Webb Telescope in terms of detecting two protostars and finding a couple of ingredients here within those stars that will be able to prove this particular theory that, hey, this is a possibility that it was formed during the formation of various systems or galaxies during its early stage. And so here it says that James Webb Telescope finds ethanol and other ICY ingredients for words. And looking at the details here, these two protostar regions here are known as the IRAS 2A and that of the 23385. And looking in details here concerning this, there are a couple of four things to keep in mind based on this particular article. One is, yes, of course, we know that James Webb Telescope is able to have this particular result here using its mid-infrared instrument technology, and this here was able to show this particular image here, and this image is a parallel field view that showcases the following: that at this particular wavelength of 15 microns, which was taken by this instrument on James Webb Telescope of the region near the protostar known as the 23385 IRAS, and also the 2A, which is not visible in this image. These were targets for a recent research effort by an international team of astronomers that used Webb to discover that the key ingredients for making potential habitable worlds are present in early stage protostars where planets have not yet formed. And so looking at the origin story now in terms of these conflicting ideas concerning whether this was formed using particular atoms on an already established planetary system or before the formation of a planetary system here, it says here that, hey, the organic molecules, which includes that of ethanol and likely acetic acid, which are essential for potential habitable worlds. Now the question that is coming up right now is that, yes, we've discovered all these particular complex organic molecules, but in what phase were they existing prior to them being deposited on planets and stuff like that? And so there were two particular conflicting ideas here. One is it in the gaseous phase or was it actually in the solid phase? And of course the article says that it's icy, and they actually talked about this particular detection of these particular compounds in ice, which suggests that the solid phase chemistry reaction on the surface of coal dust grains can build complex kinds of molecules. And so the particular process that we all know from, I would say, grade 7 or 8 science is that, yes, going from a solid phase to a gaseous phase, you actually have a process known as sublimation. And so this here, according to this article, says that sublimation is to change directly from solid to gas without becoming a liquid, therefore detecting complex organic molecules in ice makes astronomers hopeful about improved understanding of the origin of other even larger molecules in space. Now this here furthermore addresses a couple of interesting things concerning how they were in this case maybe deposited in terms of the formation of planets, where they're coming through comets or asteroids in their icy phase, and as they were approaching the atmosphere of those planets, they slowly transformed into gaseous phase. What reaction process triggered that particular process to be able to go directly from solid to gaseous, or probably from solid phase to liquid and then gaseous? So all those questions here, according to this particular part here, it is that scientists are also begin to explore to what extent did complex organic molecules are transported to planets at much later stage of protostellar evolution. Now this here molecules in cold ice are thought to be easier to transport from molecule clouds to planet forming disk than warmer gaseous molecules. Now, these icy molecules here can therefore be incorporated into comets and asteroids, which in turn may collide with forming planets, delivering the ingredients for life to possibly flourish. So these are a couple of interesting theories that are roaming around, and it's quite interesting to see this origin story here of these molecules or chemicals. The other part of this article that was actually discussed here is the detection spectrum here. As you notice here, you see that on the y-axis you have increasing in the numbers going from up to down. So that means if you have a slight dip here, you'll notice that there is a presence of such molecules in that particular protostar regions. And so what we see is that not only is the presence of ethanol or methylformate acetaldehyde, we have sulfur dioxide, we have methane, we have ethanol, we have also acetic acid, we have formic acid. But the interesting thing here is this also here, which is sulfur dioxide. And sulfur here is really instrumental in majority of cases, and it says, according to this article, that research suggests that sulfur containing compounds like sulfur dioxide played an important role in driving metabolic reactions on the primitive Earth. Now, in summary here, there are 4 things that sulfur can actually do in terms of driving metabolic reactions in primitive Earth. One is anaerobic life on the Archean Eon, and this was around 2.5 billion years ago during the Archean Eon, that where sulfur chemistry was vital for early anaerobic life, and these anaerobic organisms thrive in environments that were devoid of oxygen. That is one to keep in mind. Now, the second one is extremophiles and the microbial mats. And these here researchers studies these extremophiles, such as the thermophiles found in the vibrant microbial mats of hot springs in places like the Yellowstone National Park. And these organisms provide insights into ancient ecosystems. Now, sulfur-containing compounds, in this case here include sulfur dioxide, were present in the atmosphere during this period, and these compounds likely played an essential role in driving metabolic reaction on the primitive Earth. And finally here, point to keep in mind concerning sulfur driving metabolic reactions is the mapping bond and vibrational modes. Now, scientists used techniques to map the bonds and the vibrational modes of molecules containing sulfur isotopes, and this sheds light on the chemical reactions that occurred in Earth's atmosphere during the Archean era. That is way before oxygen became abundant. So sulfur was really a big deal then, before later we had oxygen pretty much abundant on Earth and driving so many new reactions, because of now we have a lot of aerobic species that is dominating. There are still anaerobic species here, but not that much compared to what we have right now. So really incredible to see this particular presence of sulfur dioxide, and just hits light bulb on everyone's mind concerning before Earth, or before we have, or during primitive Earth, how this was actually maybe a proof that yes, indeed, this here was the origin story of later on having oxygen presence in current Earth era. So the next point here is the final case, which involves similar to the early stage of our own solar system. Now, of particular interest is that one of the sources investigated the IRAS-2A, and this here characterized indeed as a very low mass protostar. Now, this 2A may therefore be similar to the early stage of our own solar system. As such, the chemicals identified around these protostars were likely present in the first stages of development of our solar system, and later delivered to the primitive Earth. Now, all of these molecules can become part of comets and asteroids and eventually new planetary systems when the ice materials transported inward to the planet forming disk. As the protostellar systems evolved, according to Van Dishoek. And yeah, this is really incredible stuff right here. And question is, what are your thoughts? Incredible thoughts about this particular proof here that yes, we can indeed create, or there is presence of complex organic molecules. And one more thing here, sulfur in various of protostar forming regions that will later help to form primitive planets like what we have here in terms of the origin story of Earth, primitive times, and how these might be the future regions that are actually really close to our own solar system. So all the same, I hope this you found really informative. If you think that this here is not going to have any chance of it producing planetary systems that may habit life, please drop down into the comment section and let me know your thought about this. All the same, thanks for following me through this. Truly appreciate it. See you all on the next one. Stay smart as always and believe in yourselves.